Something I always like to do is do a quick review after I finish about everything we discussed, and I would like your permission to do that. So, very good summary here. There is a shared frustration between shared business owners and engineers, but once again, they operate under different assumptions. Engineers, they're focusing on the natural and physical science, the mathematics, analysis, engineering, design practice, codes, and liability, while the shared business, they operate under margins, timelines, and client satisfaction. This was a workshop for code-formed companies. We covered some assumptions that not necessarily different designs from an engineer to another engineer will be better or worse. It depends on the assumptions for each business. And as every company is different, there is no way the engineer would know about all of the thousands and thousands of different possibilities out there if you as a shared business owner don't provide some of those assumptions that you would like to use on your business. We went through an Excel spreadsheet here comparing the different possibilities and assumptions and variables that just a small shed can have, and we got millions of options out there. So using knee bracing or not, using roof bracing or not, using fixed pin connections, what wind region we're using, what shielding factor, what bay lengths we're using, all of those different variables, they will give us totally different outcomes. We compare using ShedMate different sheds. So one using 4 bays, the other one using 5 bays. So same shed, just one portal more, and we could see that the one with one portal more gave us a cheaper outcome, which is great. Another one using 5 portals, but with C15024 using knee bracing actually became more expensive than the other solution. So there are lots of things we need to consider when assessing sheds, not only about the size of the portals, there are other factors that will play to get you a good result outcome. We discussed that cold form steel is all about buckling and that thin walled materials. So it's important that we use good bracing, and we understand that even when we're bracing, there's some buckling that can occur, like the local buckling that could happen every 60 centimeters or 600 millimeters. So it's not only a bracing that's going to solve everything. That's why the engineers, they need to assess the projects. And that means for you as a shed business that bracing systems, they're very important. If you don't like them, you need to get thicker materials. So that's why you're going to end up with probably, let's say, 250 24s instead of 250 19. Okay. We discussed different design assumptions for the connections, if they're fixed or if they're pinned, and how that impacts your footings, how that impacts your overall shed sizing. We also discussed site-specific against generic computations and what are the challenges of using generic computations when we have different wind speeds that can impact your shed design. We went through a very basic step-by-step process on how engineers we do structural analysis. So we start with the analytical model of the geometry of that shed with support types and loads. Then we can run, for example, finite element analysis tools such as robot, space gas, you name it, to actually identify those internal forces, displacements. And then for each of those cases, we can assess against the Australian code designs, the load combinations, so we can understand if the shed is going to be safe and it's going to be usable. So these are the two main checks. And also we do our footing verification to ensure that the footings we design, they make sense. If it doesn't, we go back and we do all over again with the updated frames. Then we did some assessment of two different sheds, one in Mount Gambier, another one in Port Macdonald here in South Australia. They were using the same, pretty much the same sizing, the same frames, everything is the same. But then what changed was the design wind speed. One was 37, the other one was 40. And at the end, pretty much the one in front of the ocean didn't pass on the end wall girths. So we would need to change that. So if you're using a generic computation and just applying the same for everywhere, this is a very good example that it wouldn't work. Okay. Then I presented another example. This one was done in New South Wales, one in the ocean, another one kind of about 300 meters away from the ocean. And then once again, the one in front of the ocean didn't pass. So the same applies. You gotta pick any of the two: cheap, good, and fast. So if it's good and fast, it's not gonna be cheap. If it's good and cheap, it's not gonna be fast. If it's cheap and fast, it's not gonna be good. And we understood in more detail what impacts the formula to calculate that site wind speed, including wind region, importance level, terrain category, topographic factor, etc. Then I discuss about some real world pitfalls. So just be careful about your engineering report. Have a look if it's using site specific wind or generic wind. Have a look if it's what grade of steel it's using. Specifically, if you're doing RHS sheds, you might be using something that's different from the engineering report, which can cause some liabilities there. And make sure that the regulations that were that project was designed, it's updated. It's not before 2021 when the wind code was updated. And also use a system like ShedMate to compare the cost of different design options, which is very flexible, very easy. So you can adapt that to your business and not just receive some fixed report and try to accommodate for that. So depending on how big your company are, I think you can afford having that level of flexibility to say, hey, this is how I like my sheds to be done. Let's certify them based on these specific rules and assumptions. So that's also something that can be done. As I mentioned here at ShedMate, to help companies doing fixed connections like welded and pin connections like bracket systems. We help companies doing sheds with only Zs or only top hats or C frames, you name it. So there are lots of different options out there, and we can accommodate for all of them. So the takeaways from this was always clarify assumptions, demand site specific, understand code form. This is all about geometry and buckling. It's very important. So don't rely on insurance and use tools like ShedMate to compare that. Engineers aren't trying to be a pain. And I hope that now you have more clarity to question, to align and take control of your projects, talking in a very good language with your engineers so you can understand better what they're doing so you can get a better outcome from their work. I hope this workshop was positive for you, that could bring you some clarity. If anything wasn't clear, please leave a comment below. Let me know, hey, Arthur, could you explain something more about this specific area? And then we can add future workshops on those different topics. And thank you so much for your participation. I hope to talk to you soon about your shed business and how we can help you double your shed sales without hiring more staff or franchising strings with profitability on the table. Thank you so much. Have a great one.